Anatomy of AI agents, structure, layers, and systemic intelligence in the age of large language models, LLMs, and multimodal AI systems, we stand at a turning point. What began as predictive modeling has evolved into the pursuit of something deeper, true agency. AI agents are no longer defined solely by their outputs, but by their ability to sense, think, remember, reason, and act. These systems mimic the cognitive, emotional, and behavioral patterns that make humans intelligent. But to understand where we are headed, we must first understand what these agents are made of. This article unpacks the anatomy of AI agents through a storytelling lens, revealing the interplay between structure, layers, and feedback that makes systemic intelligence possible. The core components, the mind and muscles of AI agents. Imagine the mind of an AI agent as a symphony of interacting faculties. Each one plays a unique role in helping the agent process information, adapt, and act. These are the core components that underpin intelligence. Cognition is the brain of the operation. It's where structured logic and fluid improvisation collide. An AI agent may use structured reasoning, building trees, graphs, or modular plans, to tackle well-defined tasks. But it also draws on unstructured inference, using few-shot prompts and chain-of-thought reasoning to navigate ambiguity. This duality allows agents to pivot between clarity and chaos, much like the human mind does. Memory is the thread that weaves moments into meaning. Agents need memory to maintain context across sessions, learn from experience, and build internal continuity. Whether it's a short-term buffer that retains a conversation, or a long-term repository of learned procedures, memory ensures the agent doesn't start from scratch every time it's prompted. The best systems now feature selective attention, relevance filtering, and retrieval-augmented generation to manage memory at scale. World models give agents the gift of foresight. They allow agents to simulate, imagine, and predict outcomes without executing every action in the real world. Some are implicit, living in neural weights, others are explicit, with symbolic rules or structured simulators. But all world models serve a common goal, helping agents reason about what might happen next. Reward systems are the compass. They direct the agent's behavior through feedback, both external goals and internal drives like curiosity. By learning what is rewarding, agents become capable of self-optimization. But reward also influences every other module. It focuses perception, refines memory, and even modulates emotion. Emotion modeling is the soul of the agent. While agents don't feel in the human sense, emotion modules allow them to respond appropriately to human users. They help prioritize information, adjust tone, and align with user expectations. Emotion modeling is central to making agents feel coherent, relatable, and safe. Perception is how agents see the world. They don't just process language anymore, they integrate video, images, audio, and sensor data into unified internal representations. From text encoders to 3D visual grounding, modern perception systems are turning AI into truly multimodal thinkers. Action systems are the hands and feet of AI agents. This is where decisions become deeds. Agents use action systems to navigate GUIs, control robots, execute code, or interact with web APIs. They are what turn plans into progress. 2. The systemic blueprint. From input to impact. To bring the core components to life, AI agents must be organized into a coherent architecture. This architecture is layered. Each layer processes information and passes it upward or downward in a dynamic loop. The input layer, perception, gathers raw signals from the world and encodes them into machine-readable formats. The contextual layer, memory, stores information that defines the agent's current understanding. The predictive layer, world models, runs simulations to explore future states. The executive layer, Cognition, uses these forecasts to decide what to do. The motivational layer, Reward and Emotion, modulates urgency, relevance, and alignment. The execution layer, Action, carries out the decision, completing the loop. Crucially, these layers don't operate in silos. They communicate constantly. For example, Cognition queries memory, Perception updates the world model, Reward reshapes perception. This circular feedback design ensures that agents remain responsive, adaptive, and goal-driven. 3. Dynamic intelligence, feedback loops and emergence. Real intelligence doesn't come from parts alone, it comes from the interplay between them. In AI agents, this interplay is driven by feedback. Perception informs planning. Action changes the world. Reward updates memory. And round it goes. These loops mirror the way biological systems learn, through continuous sensing, action, reflection, and adjustment. The beauty of this architecture is that it's not linear, it's recursive. Agents can re-evaluate decisions mid-action. They can interrupt themselves to reflect. They can adapt based on new input or emotional state. This gives rise to truly emergent behavior, problem-solving that wasn't explicitly programmed, but unfolds from the system's dynamics. 4. What's next? We are witnessing the birth of a new computational species, not just tools, but collaborators. From AutoGPT to say-can, from memory-rich agents to emotion-sensitive tutors, the landscape is evolving rapidly. Yet challenges remain: how to scale memory without noise. How to align rewards with human values. How to design architectures that are transparent and trustworthy. These are not just technical questions, they are human ones. The architecture of AI agents reflects the architecture of thought itself. It invites us to reconsider how we define intelligence, agency, and even consciousness.